In the name of Allah, the most beneficent, the most merciful. Assalamu alaikum. I am Usra Khalil from BS Biotechnology Department, and today I am here to present the topic of dosimetry. So let's get started from the contents, which include introduction to dosimetry, types of radiations, dose quantities, thermoluminescent dosimeters, uses of thermoluminescent dosimeters, and the general characteristics of dosimeters. Dosimetry is the act of measuring or estimating radiation doses and assigning those doses to individuals. The radiation protection regulations require licenses to control doses to workers and to the public and to ascertain these doses. Since radiation has many applications, such as radiation therapy, so that's why we need a way to quantify and measure how much radiation is being used. So that's why dosimetry deals with measuring radiations. There are two types of radiation exposure, external exposure and internal exposure. As it is straight from the name, that external means outside and internal means inside. External exposure, which occurs when radiation source or nuclear substance is outside the body. And the internal exposure, which occurs when the radiation by nuclear substances is inside the body. Dosimetry for photon and beta radiation. Beta and photon radiations are hazardous to the skin and the eye, as they can deposit energy in the sensitive cells of these tissues. So they can affect dangerous to the eye and the tissues of the body. While both photon and beta radiation can contribute to an equivalent dose to the skin and eye, photon are the main contributor to the external component of effective dose. The penetrating ability or probability of interaction of radiation is related to the radiation's energy. For example, we can say that the penetrating power of gamma radiations is very much high. Internal dosimetry involves following steps. The level of radiation inside a person's body is estimated using one of three methods. In vivo bioassay, in which direct measurement of radioactivity is in the body. In vitro bioassay, in which measurement of radioactivity is in person's urine or feces. We measure the amount of radioactivity or radiations from the urine of an individual. And the third one is measurement of radioactivity in workplace air, or we can say that environment. So here's the technique or method of in vivo bioassay and in vitro bioassay, that how this method is called. The types of radiation: alpha radiation, beta radiation, and gamma radiation. Alpha radiation, which consists of alpha particles. As it is indicated from the name of alpha radiation, that they contain alpha particles that are made up of two protons and two neutrons each, and that carry a double positive charge due to their relatively large mass and charge. Beta radiation consists of charged particles that are ejected from an atom nucleus and that are physically identical to electrons. Beta particles generally have a negative charge. Gamma radiation consists of photons that originate from within the nucleus, and X-ray radiation consists of photons that originate from the outside the nucleus. X-ray radiations are artificially produced and the gamma radiations are naturally. So the dose quantities: absorbed dose. Absorbed dose, radiation energy absorbed per unit of a mass of substance. This describes how the radiation affects the absorbing material. And the unit of absorbed dose is gray, which is denoted by GY. Equivalent dose. The concept of equivalent dose allows different types of ionizing radiations to be considered equally with respect to their potential to cause harm. Effective dose. Different tissues and organs may vary in how they respond biologically to a given type of radiation. Dosimeters. A radiation dosimeter is a device that measures dose uptake to external ionization of radiation. It is one by the person being monitored when used as a person dosimeter and is a record of the radiation dose received. Modern electronic personal dosimeter can give a continuous readout of cumulative dose, which means increased in quantity or very much high dose, and current dose rate, and can warn the wearer with an audible alarm when a specified dose rate or cumulative dose is exceeded. Other dosimeters, such as thermoluminescent or film types, require processing after use to reveal the cumulative dose received, and cannot give a current indication of dose while being born. So actually, what does the dosimeters do? A radiation dosimeter or badge dose does not provide protection but detects and measures radiation that you have been exposed to. The badge will detect high energy beta, gamma, or X-ray radiation. Dosimeters cannot detect low energy beta radiation from some isotopes, for example, carbon 14, tritium, or sulfur 35. Thermoluminescent dosimeters. This is, we can say that it is the major type of dosimeters. When ionizing radiation passes through the detector, its atoms release some of their electrons in the case of thermoluminescent dosimeters. The electrons eventually become trapped in impurities, which are also called doping centers, within the dosimeters where they remain in excited state. Excited state, a state in which their energy is elevated relative to the ground state. The chip is then heated in a thermoluminescent dosimeter reader 7, consisting mainly of a heater and photomultiplier tube and a recorder. And the trapped electrons return to the ground state and emit photons of visible light, which we can see. The amount of light emitted relative to the temperature is called glow curve. And the curve is analyzed to determine the dose. And then we can calculate the amount of dose. Thermoluminescent dosimeters there are many types of thermoluminescent dosimeters. These include lithium fluoride, calcium sulfate, and lithium borate dosimeters. Uses of thermoluminescent dosimeters. Thermoluminescent dosimeters are used for measuring gamma radiation, X-rays, and beta radiation exposures. They can be worn as rings or body badges. They contain small chips of lithium fluoride, which absorb ionizing radiation energy and display electrons from the ground state. And here are the general characteristics of dosimeters. Absoluteness, precision, and accuracy. Accuracy specifies the proximity of mean value of a measurement to the true value. And the precision specifies the degree of reproducibility of a measurement. High precision is equivalent to a small standard deviation. And dose rate range, stability, energy dependence, and incidence. Here is the short introduction or short form of dosimetry. We can say that what was actually in this technique. Dosimetry is the act of measuring or estimating radiation doses and assigning those doses to individuals. As we have read out it earlier, there are two types of dosimetry: internal dosimetry and external dosimetry. And then the alpha, beta, and gamma radiations are the main types of radiations. A radiation dosimeter is a device that measures doses uptake of ionizing radiation. And then the characteristics of dosimeters, which include absoluteness, precision, and accuracy. And these are the major properties and so on. Thank you for your attention. Have a nice day.